Okay, so we're going to look at in this video how sex-linked inheritance is different than our normal Mendelian inheritance. So when we talk about chromosomes, we can divide our chromosomes into two basic categories. You have your autosomal chromosomes, which are in humans are chromosomes 1 through 22. And you notice that we have two of each kind. We have two number 1s, two number 2s, two number 3s, etc. So when we talk about like Mendelian genetics, if someone, let's pretend, is heterozygous for eye color, that would mean that they have like a dominant allele on one chromosome and then the recessive allele on the other. We are diploid organisms. We get two copies of each autosomal trait because we have two of each autosomal chromosome. But now, when we talk about sex-linked inheritance, it's a bit different because we have X's and Y's, and our chromosomes aren't homologous or the same. So when we look at our sex chromosomes, our karyotypes are different for male and females. In females, we inherit two X's, whereas males inherit an X and a Y chromosome. So when we talk about traits that are inherited on X's and Y's, they don't all deal with like sex, male or female. When we look at the X chromosome has on average about 1,000 different genes, whereas the Y chromosome has about 30. So when we look at the X chromosome, remembering that it is a double helix wrapped around histone proteins carrying 1,000 genes, some of those genes are going to deal with traits that are not related to sex, male or female. So when we look at an example, colorblindness is a trait that's inherited on the X chromosome. It is inherited as a recessive allele. So here we would say that colorblindness's mode of inheritance is sex-linked recessive. So when we look at, though, how a person inherits colorblindness, if it is a person is colorblind, then they have the recessive allele, and not colorblind would be the dominant allele. But because it's inherited on the X chromosome, we write it like this. We actually write it, instead of just doing a B, we actually will write it on the X. So let's look at our male and our female over here. For example, if we have a heterozygous for colorblindness female crossed with another a non-colorblind male, we would actually write it like this. And so here, our female, we would write, she is heterozygous, so she has her two copies that are different, and she has two X's. However, the male only has one copy, only has one X. So the male is neither homozygous or heterozygous. We actually will call the male hemizygous because he only has one copy. So when we look at traits inherited on the X chromosome, a female can have two copies and be homozygous dominant for that trait. In this case, she would not be colorblind. A female could be heterozygous and a carrier for colorblindness, but she is still not colorblind because of that one dominant allele. A female can be homozygous recessive for colorblindness and be colorblind because she has two copies of that recessive allele. For males, it is different because they only have one X. A male is either going to be not colorblind or colorblind, and those are his only two options. There are no heterozygous males for colorblindness, unless, of course, it's the result of some other kind of non-disjunction or something. So here we have male and female and how you write their traits on sex chromosomes. If you want examples of how to solve Punnett squares with sex-linked traits, I do have lots of YouTube videos on that you can check out.